So the talk is entitled on the epistemological relevance of the ethics of maths. So there's a question of what do I mean by ethics of maths, and then why would that be epistemologically relevant, and how exactly does this play out? Well, that there is some kind of ethics of maths, I suppose, is clear. So the diversity, equity, and inclusion literature talks about issues such as underrepresentation of women in the field. This is in general for science, but this also holds true for mathematics. And I guess we wouldn't find this surprising, right? We might find this a problem. We should find this a problem. And the DEI literature discusses this as a kind of social justice issue. And rightfully so. This is a social justice issue. This should be engaged with. And sometimes we find these arguments that somehow make a vaguely epistemological connection by claiming, that we would lose talent because of the social structures of academia in general, and well, since we're talking mathematics here, also of the mathematics as an academic discipline, which is what I'll be concerned with today: mathematics as an academic discipline. And so philosophers of maths have been quite slow at picking up these kind of social power dynamics and how they might influence the epistemology. In fact, the most promising accounts of the epistemology of mathematics current today don't really feature this kind of social power dimension, because, well, again, this is a social justice issue, I suppose, so the kind of the social power that happens and influences mathematics is not epistemologically relevant, we might think. Obviously, today I'm going to try to convince you otherwise, right? The claim really is that these kind of social power relations somehow influence the epistemology of mathematics. Now, hopefully they don't do this in quite the vulgar sense as we see here, where you punch somebody to make your proof right. But you might be there might be other influences, and I'll try to show you some today, of how social power does actually play a role in how mathematical knowledge is produced, transmitted, kept alive, and so on. So that's the plan, and to show this kind of social power or ethics in the funding application. I called this the ethics of maths, but now I tend to think more on social power words. I don't know what's best for this, but here's a picture from that I used in my funding application. Lots of pictures. So the project is the Virtues and Vices in Mathematics project. And as you can see here, it sits squarely within the overlap between the ethics of mathematics and the epistemology of mathematics. And indeed, there's some more claim in here. Not only is there a reasonable overlap between the ethics of maths and the epistemology of maths, but also the project is entirely within this, and there is even space for more. So that's great, right? That's part of the claim of the funding application for this. In the funding application, I also mentioned that I want to use virtue theory. I like my virtue theory stuff, but that's not for the topic of today. But there's a goal that I would like to mention at least here, and that's these concrete interventions. Now, virtue theory tends to give us some sort of intervention in the sense of edifying accounts. Right? If we read enough virtue theory, we might know how to be courageous or how to be open-minded and what it means to be intellectually humble and so on. So this is all connected to the individual, right? This is kind of an individual level intervention. And there's this problem that I take from the criticism of Fricke's book on epistemic injustice in mathematics. And her primary case there is the testimonial injustices. And so the example really is the police agent who doesn't believe the testimony of a person because of their color of skin. And Fricke's answer to this seems to be, well, the police agent should really be less biased, right? So individual level intervention, you really shouldn't be that biased. But in a game that's broken, we shouldn't just tell the players not to use the broken parts. We should actually fix the game, right? What we need is kind of structural level intervention, something that shapes, in this case, mathematics as a discipline. So we need some kind of policy intervention. That's the idea of the structural level interventions that I'm aiming at in this project. But of course, I mean, even in the best game that is not broken at all, and I guess chess is as little broken as possible as a game can be, you can still cheat, right? I mean, there's a wonderful video of this chess hustler who was trying to cheat this chess grandmaster. Ashley Morgan, I think was his name, the grandmaster. I forgot. Anyways, even in a game that isn't broken, we still need virtuous players, right? We still need players who do not cheat, who play kind of correctly. So we also do need these individual level interventions. Besides my earlier criticism of them, I'm actually aiming for both, right? So we need the kind of structural level interventions for making the game better, in this case maths, and the players better, so the kind of edifying accounts. Of course, policing practices are not a game, nor is maths entirely a game. I mean, you know, livelihoods depend on actually becoming a mathematician and how your career progresses. But the metaphor has its limits. But that's fine for now, I hope. Okay, so right, I said here at the very top, ethics of mathematics, because that's a big new idea, right? There is some kind of overlap between ethics of maths and epistemology of maths. So what do I mean by ethics? Well, I always talk about the ethics of maths, but I'm actually quite unhappy about this definitive article here. I just don't have a better way of phrasing things. So maybe now that I'm talking to lots of native speakers, maybe you have an idea. Not that I haven't asked other native speakers yet, but I haven't come across anything that I really like. Anyways, so here are at least 3 dimensions we might think about the ethics of maths. So one is, of course, applying mathematics. And we might apply this in weapons manufacturing, and we might see this as ethical issues. Indeed, some mathematicians have, and they actively try to stay away from it, try to keep their mathematical knowledge away from the weapons manufacturing process, even though this might be futile. Okay, but there's also this kind of application of maths that raises ethical concerns, and algorithmic injustice is just one of the many aspects of this, but it's one that's being discussed at the moment. So, right, the idea there is that you can, when you write computer programs or some other sorts of algorithms, you can code in biases and so on into these formal tools. So an example I like about this is, imagine you were to write a program for US mortgage seller. And so what are the kind of entry points that you want in your program? Well, you might want the name of the applicant, you want to know what they work as and so on. But should you ask for the color of skin? Well, pretty much everybody says, no, you really shouldn't ask for the color of skin. But what about zip codes? I mean, there's a good reason to ask for zip codes, right? Because there are certain rich neighborhoods, and you might expect that if somebody is rich, then or if they live in a rich neighborhood, they might themselves be rich. And so that will influence what kind of mortgage you would sell them, right? So you might put zip codes into this kind of program. But then again, zip codes function as a proxy for color of skin in the United States. So you kind of bring the color of skin problem in through the back door by coding in this way, by writing the computer program in this fashion. And well, mathematicians have realized that this is actually quite a huge concern, and this is something very current. And societies, mathematical societies, in their codes of conduct are actually now working on implementing something along the lines of, you know, how to handle these types of applications of math to the world. But again, the application of math is not really what I'm interested in so much today. There's also this bit on the ethical nature of mathematical knowledge. So Bernard has this wonderful article where he asks why Plato's Philosopher's Kings had to study, or were supposed to study, so much of mathematics, right? And Bernard's answer is that Plato thought that both mathematics and ethics are just 2 sides of the same coin, namely the study of unity. Make of that what you will. There's this idea around, I mean, it's still contemporary today, right? So Paul Ernest also is currently arguing, right, who's still alive today, couldn't make it sadly today, but okay, that that there is some kind of ethical nature to actual mathematical knowledge. But again, what I'm actually really interested in are the kind of the academic practices of mathematics. I already mentioned the leaky pipelines that we have here. So I'm thinking quite broadly of, you know, mathematics as this human activity that people do I focus mainly on academic, or I focus solely actually in this talk on academic practices of mathematics. And I treat this kind of broadly, teaching is also included. Maybe that would be better at a fourth dimension. Doesn't really matter here. I just want to give you an idea of, what the ethics of maths might mean and how it has been discussed and what I want to be talking about today. And I would have chosen maybe a better word for it if I would know a better word than the ethics of maths. Okay, so this bit of the ethics of maths, the ethics that connects to the academic practices, I claim that influences the epistemology of maths. Now, I'm not claiming that all the social justice issues that the diversity, equity, and inclusion literature discusses affects the epistemology of maths. So not all the social justice issues are epistemologically relevant, nor am I claiming that the only bit that's epistemologically relevant are these social justice issues. I also don't really believe this. But my claim is much smaller. It's just that some of these issues impact the way mathematical knowledge is made, is communicated, and so on. Okay, so that's the claim then. How to get in there? Well, I will be relying on Katharina Dutel-Novage's three-tiered model of argumentation. Katharina is my current supervisor of my postdoctoral projects at the University of Amsterdam. So here we have some splendid, intellectual cross-fertilization going on, because I'm using her cutting-edge research stuff on the three-tiered model of argumentation. The first version of this appeared in this article in 2020, The Role of Trust in Argumentation, where she mainly focuses on Mill to get to her model. She has a new paper that is currently under review. The publication is somehow delayed because the book project is delayed or something. Anyways, she connects this to more than just Mill later on. But I think Mill gets the idea across quite nicely, even though Brendan yesterday evening sent me an email where he criticized me for my presentation of Mill. So here's my slight adaptation to this, namely that we're not really talking about Mill, but we're talking about the free exchange of ideas, this ideal of the free exchange of ideals, namely that argumentative engagement with dissenters somehow yields epistemic benefits. And if I would have been more careful in what I wrote and then sent to Brendan, I would have made clearer that Katharina is not claiming that Mill actually embraced this free exchange of ideals ideal in the somewhat naive way that is presented there, but this is what the argumentation community or the argumentation theory community has made of this, right? So the idea is that we should all just be talking to each other, and ultimately, if everybody gets to talk and say stuff, then there will be epistemic benefits. Either you already have the truth and somebody else comes to you with the wrong opinion, and then you will learn how to defend the truth better, or you might not have the truth and then somebody else comes with the truth to you, and you will now learn the truth about whatever it is, right? But of course, that's not really how things go. I mean, first of all, if you have a really good argument, or in the case of mathematics, if you have a really cool theorem and you can prove it, right? There's something really, really nice about this. But then first of all, people need to know that you have this thing, right? So just having a cool theorem and a proof doesn't actually give you any kind of credits, and it doesn't make the proof or the theorem now part of the body of knowledge, body of mathematical knowledge. And in fact, I mean, if you're a bachelor student, philosophy bachelor student at the University of Hertfordshire, and you have this really, really cool proof of a really, really cool theorem, I mean, the chances are slim that some big shot mathematician will say, oh yes, I'm going to read this. I mean, they have to divide their attention in some way, and they will probably focus on stuff that's directly relevant to them, that is that they deem as probably worthy in some way of their attention, right? There's this literature about the attention economy that Katharina refers to. There are, of course, confirmation biases. So if you, just because you have a really good argument about the nature of something, it doesn't actually mean that I will instantly, discard my wrong knowledge and accept yours. No, well, I might actually stick to mine, and I might even I might even stick to my viewpoint so much so that I enter a kind of epistemic bubble of people who think alike. This should all not really be news to us anymore, that we live in the era of Facebook and Twitter and Trumpism and whatnots, right? So there are all these problems with this ideal, the free exchange of ideas ideal. Whether or not Mill really embraced this kind of naive view, it doesn't matter here so much. What really matters is that Katharina nicely points out that, well, before we actually get to the engagement with dissenters, we first have, we have 3 stages. We have the first stage, the attention exposure stage, where the question is asking, who are our potential exchange partners? So Katharina thinks about argumentation as a form of exchange, epistemic exchange in this case, and exchange the epistemic resources, which is a very broad category. This might be bits of relevant information, really cool arguments, or the money that you pay your tutor to get to these cool arguments and bits of information. So, that is the kind of stuff that is exchanged, our epistemic resources. And the first stage is the question of who are our potential exchange partners? Who do we actually know, right? Who has certain arguments and who doesn't have certain arguments. The second stage is choosing whom to engage with. So even though the big shot mathematician now knows that you, the bachelor philosophy students at the University of Hertfordshire, has this really cool proof, right? They might still decide not to actually read that thing because they might think, well, that's a philosophy student of some university that's not famous for its math department. Why should I read this, right? I know perhaps that it exists because it's appeared on my Twitter feed or something, but I'm not going to spend some time on this. So to really get your proof out there, you got to get some exposure for your proof. Then you have to convince people to actually engage with that thing. And once they have chosen to engage with it, then there's this engagement with the content, where the engagement with the argument proper actually occurs. So here we then see where the kind of social power issues or ethical issues that I'm focusing on might come into this model, namely mostly in stage 1 and stage 2. Right, so who gets to talk, who is listened to, right? These are questions where leaky pipelines and so on might play a role. Where the stage 3, the engagement with the content, is also subject to this. I actually believe it is, but that will require more arguments and more than I have at the moment. I can't actually present on this yet. So I'll be mostly focusing on stage 1 and 2. And actually, I'll be moving beyond this model. But this is a kind of idea of how I think about kind of this process of the generation of mathematical knowledge. Okay, here are some quick fire examples then, right? So men have statistically significant greater odds of receiving a grant in science than women by about 7%. Okay, so here we might see, okay, who gets grants, right? So who is who makes it in these first stages? Who gets to talk? Who is listened to? Apparently, there's some statistically significant odds here in favor of men. In a really, really cool paper, The Diversity Innovation Paradox in Science, we learned that minority group PhD students produce higher rates of novelty but receive less uptake. So what they do is they operationalize what diversity is for a PhD thesis, what innovation for a PhD student, sorry, what innovation is for a PhD thesis, and then they have a measurement for uptake, and then they go over it's something like 1.6 million PhD theses from the United States from the 1970s to the 2000s, I think. And then they do some text mining stuff. And what they see is if you score high on the diversity scale, then you're also likely to score high on this kind of innovation parameter. But there will be, it's also likely that your thesis won't be, will receive less uptake. So this is actually just less citations. That's what they take uptake. Whatever you're interested in, this is a paper that's short enough and absolutely worth reading. So I highly recommend it. And here's this loss of talent thing that I took from the nationalacademies.org. At the argument that I mentioned earlier, the cumulative result of sexual harassment in academic sciences, engineering, and medicine is significant damage to research integrity and the costly loss of talent in these fields. So here we learn that these kind of social justice issues, in this case sexual harassment, might have some impact on the epistemology of maths because we lose the talented, right? That's the even stronger argument that we might overlook them. So, right, what happens if the next Einstein is a black woman from sub-Saharan Africa? Most likely, the scientific community will never hear about her, and we will, lose this talent, right? I'm not quite convinced by this argument, because then, of course, it would be best if we would just say everybody should play, and then we have a huge problem of attention. I mean, then what do you read if just everybody starts to publish? So that's a problem with this this kind of argument. But what I find even more problematic is that it doesn't quite. I mean, it doesn't really connect to mathematics as such, right? It connects to the sciences or academia in general. And in fact, I've been speaking to Richard Pinch, who is the vice president of the Institute for Mathematics and its Applications, and he gave me his personal opinion on this. So this is not, this is a mathematics society, and he's not giving us the official mathematics society take on this, but his personal take. And I asked him why are the codes of conduct that these mathematics societies produce, and well, the IMA has also one. Why are these specific codes of conduct? How come they do not deal with these issues, these kind of social justice issues? And well, his personal opinion was that, well, these are kind of general academic issues, right? They do not connect directly to mathematics, and so they feel that this should be handled at university level, and this shouldn't be handled by mathematics departments or mathematical societies. This is a general problem. So to really get my project off the ground, what would be really helpful and what I should be doing is to show somehow that there are some issues that are in some sense specific to mathematics, that really latch on to mathematics in particular, some ethical issues, some social power issues that influence the epistemology of maths in particular, and maths perhaps more so than other sciences. That's then the aim of the case study that I would like to present here, which is Olivia Caramello's duality theorem, which is a thing that we've discussed in the Epistemic Injustice in Mathematics piece that I wrote together with Fenner and Jean-Paul, and it's published by now. Okay, so the story is quite simply, Olivia was a young scholar, so she was a PhD and then postdoc whilst this stuff happened, and she submitted a theorem that she could prove to want to get it published in this tiny field called topos theory, right? And it's this duality theorem. What the duality theorem actually says makes no matter for what I'm going to say, so I'm not going to show you any kind of real mathematics here. In the sense of formula, I'm just showing you some real mathematics in the sense of humans doing things. And right, so Olivia submits this theorem and gets rejected on the grounds that, it's already known, we know this stuff. And then she says, well, why and where? Show me where this is in the literature. And then the story unfolds. Just to take this away at the very beginning, so nothing that's from the evidence that we gathered points to any kind of issues with her being a woman. We also spoke with her, and she also says that her gender didn't play a role in this story whatsoever. Of course, it still might, but this is not what I'll be talking about. Right? So this is not a gender story. This is her folk theorem story. And what I mean by folk theorem, I'll explain in a minute. But first, a big disclaimer: biased evidence. Right? So I'm accessing most relevant material for this mostly through Caramello's blog. So Olivia Caramello, in this entire episode, wrote emails to the main figures in topos theory, which are literally 5, right? So it's a very, very small field as mathematical fields go. And well, she published her emails and parts of the answers that she got on her website, which you can see here. So she made choices about what to publish exactly and so on. So we very much have, you know, her view on the story. And we claim that this is enough for what we want to do. Because what we do not want to do is to say, you know, Olivia suffered any kind of injustice or she didn't suffer any kind of injustice. That's not what we're really after. What we're really after is folk theorems as a source of epistemic injustice. Yeah, I make this disclaimer. We make it in the paper, and every single time I give this talk, I increase the font a little bit. Michael was there when I gave the talk at the Ethics in Mathematics 2 workshop in Cambridge. So the whole story, the whole Caramello story, played out in Cambridge, and some mathematicians got quite upset when I gave this case study. Words like, what was it, bollocks paddling idiots was thrown around. And just a few talks later, we descended into claims of fascism and so on. I highly recommend Michael's Twitter feed on this. Right? So Ethics in Mathematics 2, it's EIM2. It's a great fun to read about a conference that had a schism and was by far the most exciting conference I ever went to. Anyways, so this is biased evidence. I can't make any claim about whether Olivia suffered any kind of injustice and, you know, who the baddies are and who the goodies are. Good news for me is that's not what I'm talking about. I'm not interested in who is the goodie and who's the baddie. I'm talking about folk theorems. Okay, so right, this is an indicative story. So here is Olivia from her blog telling us that, you know, the stuff that she submitted, this duality theorem, is this well-known folklore result, right? And again, I'm going to come to folklore in just a second, right? So she goes on and asks, you know, show me where this stuff is already published or why it's kind of easy to deduce it from something that we already know. And as highlighted here, none of the contacted experts was able to provide a single reference containing a proof or statement of a result that I attributed to myself, but would have been proved before, nor anyone showed that any of my results could be deduced from previously existing results in an essentially straightforward way. Right? So the claim then is, right, so Olivia sends this stuff off to the reviewers, and the reviewers reject it by saying, well, we know this stuff, that's folklore, right? Now, folklore results are these kind of mathematical results which are taken as accepted in the mathematical community, relied upon in talks, discussion, and proving further results, but which cannot be traced to a concrete proof in the literature. So even if you've read everything in your field, in this case topos theory, you will not find this result because it's simply not there, right? That's the kind of folklore result that I want to be talking about, that we used in the paper. There we then framed those things ghost theorems because mathematicians use this word folklore quite broadly, and some of these results might actually be traced back, but it's just very difficult to do. So here we have Harrell, who worked on folk theorems for a bit, and Harrell wrote, it is rarely the case that no one knows with whom the theorem or its rigorously stated various versions originated. Rather, what tends to happen is that the effort involved in tracing back such a theorem is far greater than that involved in reproving it. So the roots of a folk theorem might be buried in some obscure lecture note, in a letter to an editor, or worse, in private communication. And I just want to mention how fundamentally human this is, right? So here we have Thurston, right, a well-known mathematician who wrote, it was hard to find the time to write, to keep up with what I could prove, and I built up a backlog, right? So as Thurston says, he could just prove more stuff than he had actually time to write, right? So of course, then Thurston might talk to somebody about this, right? This horrible private communication. So maybe the experts in the field will then know what Thurston can already prove, and they might even rely on this in their further results, even though it hasn't actually been written up yet, which of course makes it very hard for somebody like Olivia, who is a young scholar who's not yet in this circle of experts, the people in the know. In the original version of the paper, I called them the gray man with hats. Now, Andrew Aberdeen, who was our reviewer for this, he he asked, well, what do you mean by gray men with hats? I really like that image, right? Gray men with hats kind of standing around in a circle, guarding their kind of knowledge that they have. Yeah, so I couldn't quite track this down. Andrew had lots of, about gray man theory and all kinds of stuff. Actually, when I really thought deeply about this, it goes back to Momo, which is a German children's book where the gray man with hats are time thieves, and it has nothing to do, and the metaphor doesn't work at all. So sadly, we had to kick it out of the paper, even though it was such a nice picture. So now I mentioned the picture in all my talks about this stuff, but you won't find it in the actual version. So imagine, the gray man with hats who already know some stuff. And then there are the outsiders, the young mathematicians, people like Olivia, who do not quite yet know. And then Olivia goes on and, she labors hard to find the theorem and then to come up with the theorem and then to prove it. And then she wants to publish this, of course, right? She's a young academic. She needs to publish to get her career off the ground. And so she gets rejected because, the gray man with hats already know. That is the problem of folk theorems, I'll claim. So, right, Olivia played the game and lost, right? She submitted and she wasn't published. Here we have Peter Johnston, who was the PhD supervisor, and well, he said, again, this is all from Caramello's webpage, right? That Olivia is an extremely talented mathematician. She didn't make any scientific mistakes. So the problem was not that, there are any kind of mistakes with the rigor or the validity of the argument or, the way it was presented or anything. That's all not the issue. The issue really is the gray men with hats already know, right? And so here we have Steve Eovaldi, who says pretty much exactly this. He says that some of the experts know a lot more than they have published. Right? There's also some people in the field who will easily know almost anything that you can come up with, even if they have not thought of it before, which is quite strong, I have to say. And so you will not get credit or due respect for even previously unpublished results. Right? Again, Thurston here, it's the same quote, right? So that this might be all very, very human, right? So experts might really know something, and they just haven't published it yet. And then what this amounts to is that what counts as the existing body of knowledge might contain something like this kind of secret knowledge. So the knowledge that Thurston is talking about. So he already knows something, or maybe the gray man with hats knows something, and it's just not published yet. It can't be traced back to anything. We can't expect somebody like Olivia to find this. But then Steve also tells us about this possible knowledge, right? So they might even, know anything that you can come up with, even if they have not thought of it before. I mean, I'm reminded of this modern art thing, the blank canvas. I could have also done that, right? It's very easy. You just don't put anything on the canvas, and there you have the blank canvas. So that's some kind of possible art right there. But the point is, of course, I didn't, right? So I guess Steve is really, really out there at this point. And in fact, that's exactly what we argue. So we argue that possible knowledge is an unjust standard for judging new pieces of mathematics, in this case as a reviewer, right? So there's a kind of intellectual dishonesty about this. There is we make these points a bit longer in the written version, but I'm just going to brush over them here. There's a kind of intellectual arrogance in saying, if you could do this, then I certainly could, because you are just the new mathematician and I'm this established figure, and obviously I'm very smart. It also runs the risk of misidentification of reliable authority. Here's a very lengthy quote where Andrew Yoyle tells us that he thought that he could easily deduce this theorem that Olivia proved from this other from this stuff that Mackay-Ray's theory. And then he actually tried to do this, and he found out, well, it's actually much harder, and it doesn't really rely on what I thought, and it's actually more complicated. And with my great astonishment, it took me a night of work to construct a proof based on my knowledge of the subject. And he is one of the 5 experts in the field. And then from this experience, he draws the conclusion that, well, actually, he had misread Caramello's paper, that, the duality theorem may falsely appear straightforward, that the result is not trivial, and it is actually original, right? So he kind of misidentified himself as a reliable authority about what counts as the existing body of knowledge. And we then go on to argue that secret knowledge is also an unjust standard for reviewing new bits of mathematics. So it fails to promote the virtues, right? So you, even if you are a very meticulous researcher who comes up with this rigorous proof, and you've done all the good stuff for kind of good mathematical research, you still won't get published, right? You still get punished for this because the gray men with hats already knew this stuff. So, well, your problem, right? Of course, in Olivia's case, she had this theorem, and right, she had this idea for the theorem, and she could have gone around asking people, well, do you already know this, right? So maybe she should have done this. But notice that this is reckless, right? This promotes recklessness. This promotes the potentially dangerous behavior of going around telling people, here's this really cool theorem that I can prove. Do you know anybody else who has already proved this? If you go to the wrong person, this person might be smart enough to, prove the theorem themselves and then publish on it before you do. So that's a problem. And then there's this point about the harm to the rejuvenation of the practice of mathematical practice. So here we have Steve again, who gives advice to Olivia and says that I've also felt that the field of topos theory, which is where the duality theorem plays out, is not a good area for new researchers, in part because some of the experts know a lot more than they have published. My own response to this problem was to look for other areas than topos theory to work in, preferably ones in which those experts were not also working. So his advice then is, don't work in such a field where you have some gray men with hats, right? This is what Thurston says again. I mean, to quote Thurston here, it feels really weird. Brennan wrote a paper, right, entitled "What Thurston Said," or what Thurston says. I don't know. Anyways, where he charges us philosophers of maths to just rely on Thurston all the time. And now I'm doing this here. Of course, he charges us for relying on it in the wrong way, in the non-smart way. And I claim that the way we do in this paper is actually smart. So there you go, Brendan. Well, so Thurston tells us here, very much similar to what Steve says. Well, I heard from a number of mathematicians that they were giving or receiving advice not to go into foliations. Foliations is the mathematical discipline that Thurston was working in. They were saying that Thurston is cleaning it out. People told me not as a complaint, but as a compliment that I was killing the field, right? So there's this idea that if you have, experts who are so much in the know, then, right, that these gray men with hats have so much secret and perhaps even possible knowledge that they're guarding, that you will just not make it in. And the solution to that is don't even try. And well, obviously that we claim is bad, and we've given arguments why, right? We've given the problems of why kind of secret knowledge and possible knowledge are unjust standards for reviewing mathematical work. Michael Barr, who's one of the other experts that Olivia contacted, kind of agreed with her and said that in general, he would say that any result that is well known folklore should be published. So Olivia should have been able to publish her duality theorem, if only for the reason that it then can be cited. Well, actually, Fenner and John Paul and I have given another reason, right? These kind of ghost theorems, these theorems that you cannot be traced back to the literature. They promote this form of secret knowledge that I've been talking about. And secret knowledge, we argue in the paper, is a source of epistemic injustice. So epistemic injustices are injustices that occur on a specifically epistemic dimension. You have one example here. I already mentioned one earlier when I was talking about Fricker and the testimonial injustices, where the police agent does not believe the testimony of a person of color. There are various other instances of epistemic injustices. But so the claim here is that there is there's some unjust standards in what counts as existing body of knowledge. And well, we claim, to publish these kind of folklore theorems, or these ghost theorems, would help to dry out this source of injustice. Right? So this is a structural intervention that we're proposing here. Right? There's some kind of policy recommendation that there should be a place to publish folklore results, which there currently isn't really. There's no journal dedicated to folklore theorems, for example, or journals will reject you, like in the case of Caramello, when you publish something folkloric, or we would like to publish something, submit something. Okay, so here our structural recommendation is, well, there really should be something like this. So what are the next steps then, right? So there's this caricature conclusion. I've been talking about the DEI literature and, let's be more inclusive. And the caricature of this is, of course, the big huzzah for diversity. Let everybody play. Everybody should be able to do mathematics, and that syncs up nicely with Medina's idea of epistemic friction. So Medina is harvesting Foucault here, and of course Foucault is one of the big ones who argued that knowledge and power are deeply intertwined. And this idea of epistemic friction is basically that you always have these forms, these subjugated forms of knowledge, subjugated knowledge as he calls them, Medina that is. And he is thinking mostly in terms of oppressed minority groups. So let's say, the prime example is always, African Americans in the United States. And how they have forms of knowledge that are oppressed, and there are others who have other forms of knowledge. And Medina is making the case for kind of guerrilla pluralism, where we should accept that these forms of knowledge might clash, and there might be no resolution, and that there's something very positive about having this constant epistemic friction, that you have these different types of knowledges, and they should all be kept alive and fight against each other. But there's this notion of mathematical cranks, right? And that, I think, goes quite against the epistemic friction idea. So mathematical cranks are these people, mostly apparently mathematicians at least think so, retired people. I didn't know this, but I recently read about this. So these are mostly non-mathematicians who write to mathematics journals where they claim to have disproven some famous theorem. Let's say Gödel's second incompleteness theorem. That's a favorite one, or Fermat's last theorem, or something, right? They come up with these proofs that usually don't work, and mathematicians regard them as cranks, right? They somehow do not meet the standard. And I mean, this is my intuition. This is, like I said, it's the next step. So this is something that I would like to talk to you about. Maybe some of you have ideas about this, of how to accommodate this idea that, well, huzzah for diversity, yes, I do believe so. Huzzah for diversity, yes, the pipeline is too leaky. Yes, we have, massive underrepresentation of minority groups in mathematics. And I do believe that it's a problem that, the Fields Medal never went to sub-Saharan Africa, for example. There's something problematic here, but nonetheless, there are also these kind of standards of excellence, if you will. Something about, mathematical knowledge that doesn't really go so well with the idea of epistemic friction and constantly fighting different bits of knowledges. So that's what I'm currently thinking about. I mean, by currently, I really mean currently. I started, I think, last week, maybe a couple of days earlier, to read up on this, think about it in these terms. So this is very, very new stuff, and I won't be talking much more about this. Rather, we can go to question time, because that was it from me. Thanks a lot.